Hello, and welcome to this beginner-friendly deep dive into control flow statements in programming. Understanding control flow is fundamental for any aspiring programmer, as it dictates how your program makes decisions and repeats tasks. Without it, your code would simply execute line by line, unable to adapt or perform complex operations. Today, we'll embark on a comprehensive journey, covering the essential conditional statements like if, else, and switch, which allow your programs to choose different paths based on specific conditions. We'll then explore the powerful world of loops, including for, while, do while, and for each, enabling your code to efficiently repeat actions. Finally, we'll examine break and continue, crucial control statements that give you fine-tuned command over loop execution. We'll go step by step through each concept, providing clear examples and practical tips to solidify your understanding. This video is designed to be fully explanatory and detailed, ensuring you grasp the core principles. Let's get started on mastering control flow. Our journey begins with the if statement, the most basic form of conditional logic. It allows your program to execute a block of code only if a specified condition evaluates to true. The syntax is straightforward. If followed by a condition in parentheses, then a block of code enclosed in curly braces. For instance, if we want to check if a person's age is 18 or above, we'd write if console.log. If the condition age greater than or equal to 18 is true, the message adult is printed. This simple yet powerful construct is the cornerstone of decision-making in programming. A crucial tip for clarity and to prevent common bugs is to always use curly braces for the code block, even if it's just a single line. This practice enhances readability and maintains consistent code structure, making your programs easier to understand and debug in the long run, especially as your code grows in complexity. Building on the if statement, we introduce else and else if. The else statement provides an alternative path of execution when the if condition is false. So if is false, the program will execute the code within the else not a block. This creates a clear binary choice. For situations requiring multiple conditions, we use else if. This allows you to chain several conditions together, where each subsequent else if is checked only if the preceding if or else if conditions were false. Consider a comprehensive grading system. If I, else if B, else if C, else if D, else F. This example clearly demonstrates how different grades are assigned based on score ranges, providing a structured way to handle multiple outcomes. A valuable tip here is to avoid deeply nested if statements when possible, as they can quickly become complex and hard to follow, leading to spaghetti code. For many discrete conditions, a switch statement often offers a cleaner and more efficient alternative, improving both performance and clarity in your code by centralizing the decision logic. The switch statement is an excellent choice for handling multiple exact matches for a single variable, offering a more structured and often more readable alternative to a long chain of else-if statements, especially when dealing with a fixed set of possible values. Its syntax involves switch followed by the variable in parentheses, then multiple case labels, each corresponding to a specific value. For example, switch case 1, Monday, break, case 2, Tuesday, break, case 3, Wednesday, break, default, invalid day. Here, the program executes the code block associated with the matching case. A critical tip is to always include a break statement at the end of each case block. Without break, the program will fall through and execute the code in subsequent case blocks, which is usually not the desired behavior and can lead to logical errors. Additionally, always include a default case to handle any values that don't match the specified cases, ensuring your program behaves predictably for unexpected inputs and provides robust error handling. Now, let's delve into loops, starting with the for loop, which is ideal when you know exactly how many times you want to repeat a block of code. The for loop's syntax is compact and powerful. It includes an initialization statement, a condition, and an increment or decrement statement, all within the parentheses, followed by the code block. These three parts control the loop's execution. For example, to sum numbers from 1 to 10, you'd write, for sum plus equals I. Here, I starts at 1. The loop continues as long as I is less than or equal to 10, and I increases by 1 in each iteration. This loop structure is incredibly versatile and commonly used for iterating over arrays or performing tasks a fixed number of times. A key tip is to ensure your initialization, condition, and increment statements are correctly defined to prevent infinite loops or off-by-one errors, which are common pitfalls for beginners. Careful planning of these components ensures your loop behaves as expected. Next, we have the while loop, which continues to execute a block of code as long as a specified condition remains true. Unlike the for loop, the while loop is best suited when the number of iterations is not known beforehand, and the loop's continuation depends entirely on the condition becoming false at some point. The syntax is simple, while code. Imagine a guessing game. Let guess, while guess equals prompt. The loop keeps prompting for a guess until the correct number is entered. This demonstrates its utility for indefinite repetition. A crucial tip to prevent infinite loops is to ensure that the variables involved in your condition are updated within the loop's body. If the condition never becomes false, your program will get stuck in an endless cycle, consuming resources and freezing your application. Adding a counter or modifying the condition variable is essential for proper termination and predictable program behavior. The do-while loop is a variation of the while loop with one significant difference. It guarantees that the loop's body will execute at least once before the condition is checked. This makes it distinct from the while loop, where the condition is evaluated first. The syntax is do code while. This structure is particularly useful in scenarios where you need to perform an action at least once, such as displaying a menu to a user, and then continue looping based on their input. For example, do show menu. Choice equals get user choice. While. Here, the menu is always shown initially, and then the loop continues as long as the user doesn't choose to exit. The key tip for do while is to use it specifically when the body of the loop must run at least once, regardless of the initial state of the condition. This ensures that initial actions, like presenting options or validating user input, are always performed, making it ideal for interactive prompts. The for each loop, often found in languages like JavaScript or C#, provides a concise and elegant way to iterate over elements in a collection, such as an array, without needing to manage indices explicitly. This simplifies the code and reduces the chance of index-related errors. Its syntax typically involves specifying an item variable and the collection you want to iterate over. For example, in JavaScript, you might use array.forEach to print each item in an array. This loop simplifies code when your primary goal is to process each element sequentially. A helpful tip is to remember that for each loops are generally designed for read-only iteration. While you can access each item, directly modifying the collection structure during a for each loop can lead to unexpected behavior or errors. It's perfect for processing lists or performing actions on each item. But if you need to manipulate elements by their index or modify the collection itself, traditional for loops are more appropriate and safer. Finally, let's explore break and continue, two powerful control statements that give you precise command over loop execution, allowing for more dynamic and efficient code. The break statement immediately terminates the innermost loop it's contained within, transferring program control to the statement immediately following the loop. For instance, in a for loop iterating from 1 to 10, if you include if break, the loop will stop when I reaches 5, even if its original condition would allow more iterations. The continue statement, on the other hand, skips the rest of the current iteration of the loop and immediately proceeds to the next iteration. If you have if continue inside a loop, it will skip processing for even numbers and move directly to the next odd number. A key tip for break is to use it sparingly for early exits, such as when a search item is found, to improve efficiency. For continue, it's excellent for filtering data within a loop, allowing you to process only relevant items. Always add comments explaining why you're using break or continue to maintain code readability and prevent confusion, especially in complex code bases, as their abrupt nature can sometimes make code harder to follow. We've covered a lot of ground today, diving deep into the essential control flow statements that form the backbone of programming logic. We explored if, else, and switch for making crucial decisions in your code, allowing your programs to respond dynamically to different conditions. We then delved into the world of loops, mastering for, while, do while, and for each to efficiently handle repetitive tasks and iterate over collections. Finally, we learned how break and continue provide fine-grained control over loop execution, enabling early exits and selective skipping of iterations. The most important tip for mastering these concepts is consistent practice. Start with small programs, experiment with different scenarios, and don't be afraid to make mistakes. When debugging control flow issues, remember to use print statements or a debugger to trace the execution path and variable values, which can reveal exactly where your logic deviates. Your next step should be to combine these control flow statements in more complex projects, building real-world applications and seeing how they interact. Thanks for watching. Now go forth and code.